So write the standard form up here first, please. X minus h squared divided by a squared plus y minus k squared over b squared is equal to 1. When you do a circle, it's always equal to the radius, the square of the radius, rather. For an ellipse and hyperbola, it's equal to 1. So when you're working out equations and you get a number on this side, just divide by that number and you get 1 and you divide on both sides. That's how you end up with the 1. But it's always equal to 1. Now we'll talk about the parts of this here. Okay? And so what I want to do is in the center of this, let's do about the center of it, we'll do a center. And let's go out 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's good enough. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. And let's go up, I don't know, 5 or 6 or 7 or so. Enough to have lots of room to write in. 4, 5, 6. So I'm going up and down 7 and out 12. And then I'm going to make my attempt to make some curves to it. Yeah, okay, that's one of my so-so football type of ellipses. Could be a little bit better, but it's basic idea. And then I'm actually going to draw these lines. So we call this one the major axis, and we call this one the minor axis. Terms actually make some sense. Major and minor. Major's larger, minor's shorter. Okay, that makes sense. And for the minor axis, see the distance here? That's called the amount b. And this distance here is a. Back to the equation. That's a from the center out to there to the end point, and that's a squared here. If you know this amount, you know what to put in the equation. If you know this, you know what to put in the equation. So if I told you that the length of the whole major axis was, in this case, I don't think I want 12, right? Okay. If the length is 24, half of that is 12, so this would be 144. I went down 7 here, so this is 7, so that's 49. Now you have pretty much half of the thing. In fact, right here, the center, that's H and K. That's the center. And so right now I would know enough. If this is the center, and if this is the x and y and x axis, I would have x minus 0, y minus 0, just x squared and y squared, and I'd have 144 and I'd have 49, and I'm done. There's the equation. Okay. If this was somewhere moved around on it, I just simply have a different h and k in there. So that's all you need. So that means if you know the distance here and distance here, you're good to go for the equation. Now let's see some other things. Somewhere in here, now let's put a couple of points here. I'll call this focus point 1. Focus 1 and focus 2. It really doesn't matter which one's which, it's just that there's 2 of them. And the endpoints, by the way, are called vertices. So here's a vertex 1, and here's a vertex 2. And it doesn't matter which one you call 1 and 2, it's just that there's 2 vertices. They don't have a name for the endpoints here. The minor axis endpoints, they don't really have a name for them. At least I haven't used one and haven't seen it in any of the things I've studied. Now, the focus point here, there's a focus point. We call that this little part here. Now, there's a distance here. A is the distance from the vertex all the way to the center, including the extra part past the focus point. And B is this one from endpoint to center. A, B, there's a C. Yep, we call that C. And you've heard of the Pythagorean theorem. We don't use the Pythagorean theorem. We mess it up here. C squared is equal to A squared. Notice that. Little stars around it. Notice that. So if you didn't know how much A was, but you did know how much C was, what the distance is, you could plug in C and plug in B and figure out what A is and be able to make the equation. So that's going to show up a little later here too. Okay, let's see. These are most of the points. In fact, that's pretty much all the stuff that's on an ellipse. So you know where a center is? That's an easy one, but you need to know major axis, minor axis, know the distance of A, distance of B, and distance of C. Yes?
How do you decide where to put a focus point?
Good question, and we're going to do that. There's a, actually, there's a method for it, and the number one method is using this. You get A and B, and it tells you the distance of C, so you go from the center out that direction, and then you find the focus point. That means in order to get the focus point, you have to know these two things. So usually, you're given some information to get these two, and then you get that, or you're given something about the focus point, and you use that and one of the others to get the third thing. So usually the focus point, in fact, always is dependent on the other two. And so this little formula will help you get that. We're going to use the same formula, similar formula for the hyperbola. For the hyperbola, we revert back to the real Pythagorean theorem, so it's a squared plus b squared. But remember that it's different for this one. Because if you don't, you end up messed up here. And it makes sense. The C is definitely smaller than the A. So C squared cannot be equal to A squared plus b squared. The C would be bigger. On the hyperbola, it is. The C is out on the outside, past the vertices. You'll see that when we do that one in a few moments. Okay, this one being done, let's see if I have enough of my ellipse papers. Sure, thank you. Okay. Take two of these so you can have an extra. I'm not sure if we're going to do two of them, I might, but let's have you take a couple. Pass them and I'll collect the extras. So the ellipse paper I use is slightly different because there's different requirements. There's different characteristics of an ellipse. So the center is the center. In fact, the parabola doesn't have a center. It has a vertex. But the, and I think there's more common extras. Great, thank you. Thank you. And I'll use this one here. This one here, the graph one. So let's take this equation. Let's see, do I want to do which one? Two of them. I think I'll do two of them. Okay, x plus 1 squared divided by 36 plus y minus 2 squared divided by 4 is equal to 1. That's the one I think we'll work with first. The coordinates of the center, we think the same thing we did with the vertex and the parabola. We use the h and the k. There's our h, and here's our k. But because they're inside the parentheses and squared, that means we have to use the opposite signs for both of them. So that means the center is going to be a -1 and a +2. I'm going to go down here and put it in there. Okay, -1, +2, there is the center. Now, I have enough information to pretty much graph it right now. Because if that's 36, the square root of 36 is equal to 6, and that's what the A is. Because remember, that's A squared. So A squared is equal to 36, so A is 6. And this one is B squared. If that's B squared, then B is going to be equal to 2, because it's the square root of 4. So we now know that the A is 6 and that the B is 2. Which way do we go? That's one of the other questions. Should I have that 6 going out this way and this way, or should I have the 6 going this way and this way? The way you know, the easiest way that I use to remember it, is that the A, the larger one, is underneath the axis that you're parallel to. If it's underneath the x, that means we're parallel to the x-axis, so I'm going to go 6 this way. and 6 this way. If that 36 had been under the y, then we would have gone up 6 and down 6 because it would have been parallel to the y-axis. That's the best way that I've remembered it. There's a few other ways you can probably think of it, but I've never heard it explained well any other way. So, and it's always worked for me. I always get it in the right place. So that one I'm happy with. That means the other one goes this direction, down 2 and up 2. And I can sort of draw it, you know, like a box in there. Okay. And now that helps me for a few other things, because if I want to know the vertices are these two endpoints. So I just go out to, let's see, it looks like that's -7 and 2. So -7 and 2. And if I go this way, it's at 6 and 2. So once you draw it, this is a case where drawing it is the best thing to do right off the bat. Because once you draw it, now you can use these pieces to it. I'm going to skip focus point for a moment. Let's come to the major axis. The length of the major axis is the whole thing, not just 6, but you have to double it to say 12.
It should be 5.
1, 2, 3, 4. You're right. 1, 2, 3, 4. Yep, you are right. Thank you. Oh, don't go too fast like I